Great. A NumPy array, which is also, being constructed by Python literals. And then you can both versions. Actually, I'm kind of serious. Let's do this. Let's print these guys. Let's see what happens when you print them. All right, Python, quick. Here we go. It is, okay, that's neat. It automatically is using the hardware accelerator on the what is going on? I can't believe it's doing some Python deep learning AI. We're learning a new framework today called Tinygrad. We're learning Tinygrad. Okay, so we can do a whole bunch of nifty things here. It looks like we can create a whole tensors directly with like this. I like this better. I like to be able to, let's add this in here. Let's see. So we could also do tensors like this. That's pretty interesting. I like that. We could do that. That's pretty neat. So full, which you can fill automatically with some value. I would like to fill it with random values. That's what we're doing. What do you call artificial intelligence with Python and Tinygrad, which is an AI framework similar to PyTorch. And we can do create a 3x3 identity matrix. The one thing what I would really like to see is when I print T2, is it going to print? Let's see here. Is it going to print? See, I don't want it to print that. I want it to print the actual contents. I want to see the actual contents there. Windows subsystem layer for Linux. There you go. Uniform, create a tensor of shape filled with random values from a uniform distribution. So a uniform distribution allows you to smooth out the model, giving you a range. So it's not every unit is random. It maintains a distribution. Otherwise, it's just full random or uniform random. And that's kind of interesting. I like that. AI deep learning with the Tinygrad framework by GeoHot. If you're familiar with I remember GeoHot from our early days that did the jailbreaking on the iPhone. The operating system always had some sort of hole or two. GeoHot was always able to find it. Is there like a CPU? There's no CPU. Okay, so in PyTorch, you can say .to CPU to extract the data of the, take it from, because right now, maybe the problem is when we're creating these tensors, we need to set, it's going to my GPU accelerator. So I'm trying to print out data that's on the GPU memory, and it's crashing Python. So, what is Tinygrad? Yes, you're right. Check this out. Tinygrad. And let's see, is it here? All right, so Tinygrad GitHub. We type Tinygrad GitHub. So this is it. I like how they titled this the about section. So do you like PyTorch? Do you like micrograd? Then you'll love Tinygrad. So it's basically the very same. What is that tensor.random? Oh, okay. So tensor.random, which is right here. This will create a multi-dimensional array of a 2x3 matrix. There you go. Let's jump back into our tutorial here. Let's finish our tutorial. This is the plan for today. We got to get our tutorial finished. So this crashes. Is there a way we can change the device? Here we go. I need to be able to change the device. This is what I want. I want to change the device because right now I'm pretty sure that's what's causing the crash. How do we change that? I want to change it to CPU. It's automatically putting it on my GPU hardware accelerator, which is a problem. It's running it on Mac, right? Which is the Metal framework. So it's running on the Metal framework right now. What? Method. I thought that was something else for a second. I thought it was something else. All right. So, okay. So .to NumPy. I need to be able to change... wow, this can't be the Quickstart. Is this still the Quickstart? There's no, this is not the Quickstart. Okay. Device. Here we go, device. All right, so maybe there is an unsqueeze. Maybe we need to do an unsqueeze first. I don't know. We're going to find out. Let's see if we can get it. Let's see if we can get it to not crash anymore. Unsqueeze. Is that going to work? Is that going to work or is it going to cause it to crash? Nope, it crashed. There you go. Python quit it unexpectedly. Ignore. Okay. We need to, so let's do this. Tinygrad. We need to move tensor to CPU. Let's see if we can do that. Let's see if that's possible. Here we go. All right, so tensor1's.gpu. Oh, .cpu. Okay. Really? I tried that. I tried it. It didn't work. Aspects make you say AI is the most difficult thing. It was hard. It was really hard to learn. There was a lot to it. Usually, like, you can do a framework, but I mean, if you look on the screen, we haven't even done AI yet. We haven't even done any AI, and we're still at the beginning here. So let's see. .cpu. Can we do that? Is that going to cause it to explode? Let's try this. .cpu. Here we go. Is it going to work, you guys? Is it going to work? It's going to do the thing I finally wanted? Uh-oh. Wait. Whoa, that's weird. Oh, because I'm using new Python. .cpu tensor object has no attribute. Look at, see, this is why right now. See this right here? The AI got it wrong. You guys. See, the GPU tensor. So maybe we do. All right. So maybe it did get it right. We need to give it a chance. Let's see what the device is here really quick. Let's see what this is. Let's see before. All right, here. We'll see. Paste. There we go. F dot. Nope. There we go. Delete that. Comment that out. Pop over here. All right. What is it? Device. Oh, .cpu. Okay. We don't need that. Obviously, that's not a thing. It's not. Boop. There we go. All right. Bum. All right. Let's see. It is on metal. See, it's on the metal. We need it to be CPU. We need it to go to the CPU. We need it on the CPU. Otherwise, it's going to crash. I'm pretty sure that's what's causing it to crash. CPU tensor. All right. Let's see if that works. All right. Python. Oh, it works. Okay. It's on CPU. Perfect. Okay. So then can I do print CPU tensor dot NumPy? Can we do that? Is that going to work, or is it going to crash that too? It works. It works, you guys. Look, we did it. We got an actual array to print out without crashing on the device. All right, so we're doing good now. All right, we can move on. I think AI plus Internet of Things has the most potential. It sort of bridges the gap between human sense and AI's lack of the sense. Oh, you're right, because it brings our intelligence on the computer into the real world. Some photo sensors, heat sensors. What other kinds of sensors are there? Pressure sensors, right? WebAssembly. Wait, a WASM? Are you talking about WebAssembly? Wait, what are you talking about? What is a WASM? Solmail. What is WASM? Plus, they're running out of training data. You're right. So we need more data. We need more input. Hey, we solved the problem, you guys. I'm so happy about this. So all we have to do is say comma device equals CPU. And it'll prevent it from crashing. Obviously, it's going to make it difficult to train because we won't use GPU accelerator on my device. But I think we're fine with that. I think we're fine. I'm perfectly happy with that. All right, let's pop over models. All right, let's make our own model. We're doing it. We're going to make our own model now. Let's copy it. All right, so neural networks in Tinygrad are really just represented by the operations performed on the tensors, because the tensor is like the main thing, right? The operations are commonly grouped into the call method of the class, which is a double underscore method in Python that allows you to invoke the instantiation of the class, right? The class instance. When you call it, it will run that function. So that's what that does. You guys. Kudos. Let's jump into it. Let's make our own model. All right, so an example of this would be the linear nn.linear class, which represents the a linear layer in neural network. So, all right, got it. Okay, so linear, this will be linear, which is just, all right, so this is very similar. All right, so we need to define our weights and biases, out and in. Okay, so let's do that. This is actually going to create a full, x.linear is a thing. .transpose, all right, so there is a transpose method. I was wondering about this. This is a transpose method. Okay, so let's copy this and run it. Let's copy and run it. Set paste. We'll set paste. Here we go. There we go. All right, so we've got our own model. Let's close off some of these prints here. We want to clean output. Let's do some clean output. All right, so here's our class. Let's then L equals linear. Oh wait, disable paste. Set no paste. There we go. Linear. There we go. So features in, features out. Okay, so this will be a 10 in and 1 out. Bias true initial uniform. All right, Kami. Yeah, we'll do Kami uniform. Excellent. I like that. All right, so print L. I'm just curious to see what's going to happen here. All right, let's run it. Python Quickstart. All right, there it is. It is our own class. So obviously there's nothing to print. So we need to find like a two string here. Let's do that. Let's do it. Let's make it happen. All right, I will do. So what I want is, I think str, right? That's what we want. It's str. There we go. Str. This is basically a feed forward network. So we could probably also do L like this, right? So we L, and then we need to put a tensor. So let's do, what is it called? We need T10 equals a tensor 10. No, was it? No, just 1 by 10, I think. A 1 by 10. And we say T10 out equals print out. Let's see if it works. Let's see if the feed forward neural network works, you guys. Let's see if it works. It did. It worked. It worked. But let's put it on a CPU. Let's put it on a CPU. Tensor initialization. Oh, what? Initialization. How am I supposed to? Oh, okay. Wait, can I say device equals CPU? Can I do that? Can I do that? Tensor dot device equals CPU. Device equals CPU. Let's see if that works. Oh, then we also need to say device CPU there. And we can print out. Let's see if that still works. Does it still work? It still works, you guys. It still works. Okay, and so the output looks correct. And we could say NumPy here. I believe we could do that. I believe we could say NumPy now because it's on the CPU. Because if we do it the other way, it'll crash. Hey, there it is. It's exactly what I was looking for. What are you teaching? Oh, we're teaching our deep learning AI today. We're doing AI. We're learning it with the Tinygrad framework. You see here the Tinygrad framework? Right there, the Tinygrad framework, which is very similar to PyTorch. It's very similar to PyTorch. So we just created our own feed-forward neural network. Right, we're going to do MNIST now. We're going to do the MNIST dataset, which is a bunch of handwritten characters. So if you're familiar, MNIST dataset. Check this out. Here it is. It's a bunch of handwritten characters. Tinygrad. We're doing Tinygrad, which is an AI framework. It's very similar to PyTorch, and we're getting it going. So we're doing PyTorch today. All right, so we need to find our loss function here. This is the loss. Okay, sounds building something similar to GPT. Today we're doing OCR, optical character recognition. That's what we're doing today. Optical character recognition. That's what we're doing. The MNIST. So here we go. Stochastic gradient descent is going to be our optimizer. Looks good to me. So we're going to use the SGD. SGD for stochastic gradient descent, you guys. All right, let's open that up. Our optimizers here. There we go. We got our optimizer. We've got our net. We got to put our net up here because otherwise it won't work. Let's run it and make sure it works good. All right, it's working good. We're looking good. Is Tinygrad good? I thought it was a premature framework done for fun by GeoHots. It is by George Hotz. You're right. George Hotz. You got it. That's right. It's okay. It's doing okay. It does crash. It crashed, but you know what? We're gonna keep trying it because you know what? We're learning things. We're learning some new stuff here. We're learning some new things, you guys. All right, so here's our loss function. There's our loss function, and here's our optimizer. We got our loss function. We've got our layer, a linear layer, and then we've got our a model. So this is our model. So TinyNet is the model. So here, let's annotate this. This is the model. This is a layer. A layer just is basically it's a 2D matrix. It's a 2D matrix. There you go. With plus a 1D matrix. Plus. So plus, there's also a bias. Plus optical character recognition, Mr. Axe. Mr. Axe. All right, you asked the right question. All right. So see here, we've got a bunch of handwritten digits. See all the handwritten digits here on the screen? This is like 0 through 9. They're all different shapes and sizes. Like, see the 7? Sometimes the 7 has a line through it, and sometimes it doesn't. What you can do is you can train an AI model to recognize all the handwritten letters. And when you do this, it allows the AI to read, basically. It allows the AI to read images. So that's what we're doing. That's what we're training. So I would like to be able to finish this. Let's see here. That's the capable of doing the AI. Oh, that's what we've done so far. If I start from today, where should I begin? Can we get access to this AI you're building? Yeah, sure. Absolutely. Well, you know what? You don't even need to because it's public. We're just copying and pasting it from the Quickstart tutorial. So it's actually pretty easy. So we're going to fetch the data now. Now we need to fetch the data. We need to download the image data. So we're going to download the image data, you guys. Building an optical character recognition artificial intelligence, which allows the AI to read handwritten characters. In this case, we're doing simple digits 0 through 9. This is kind of the hello world for artificial intelligence applications. So that's what we're building right now. And we're doing it using Tinygrad, which is a small, simple, clean, hardware-accelerated deep learning framework written by George Hotz, and it works pretty well. I would say I'm pretty happy with it. I'm very happy. What we need to do though is we need to install the extras. So how do we install this? I don't know what the module is called. So let's see here. I'm going to copy paste this really quick. What you do here is go to Google and it's going to tell us what module I need to install. Okay, this is it right here. Import. There we go. So see, it was an obvious, right? Python MNIST. All right. So let's pop that in. Let's install it. There we go. All right. Let's run our. Is it good? It's still not found. So that's still a problem. Let's see here. Oh, maybe. So we could probably import it from another library. We might. Extras module included in fetch is typically from a larger library you need to identify. It is. So no module from extras. So let's see here. From scikit-learn. So we need to go further. This is Tinygrad. Here. Let's see. Let's give it more context. So let's give it more context. We'll grab it here. Like that, and then we'll say we got a tqdm. I don't know what that is. Let's add that though. Let's add tqdm. Pip install tqdm here. Let's grab that really quick. All right, tqdm. All right. Anything else? I'll try doing this, but I don't think that's necessary. I already installed. Okay. Python Quickstart. Does this still work? Nope. Still a problem. It's still a problem. Let's see if we can fix that. Let's see. Still a problem, still happening. So we need, you know what? We might need to read the docs. I think what we got to do is read the docs. Get present working directory, fetch MNIST, extra dataset, reset, Python, blah, 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 install qtoe. What we need to do is we'll read the docs. So, here. Oh, here it is. All right. Now that we have our network loss function and optimizer defined, missing the training data, there are a couple of dataset loaders located in extra datasets. We'll need to be using, okay, so we need to fetch the data from here. This is what it is. Where is it? From tinygrad.in.datasets, import MNIST. Okay, let's try that. Let's try that really quick. Let's try it. I'm going to copy and paste that. Thank you, Kevin McAllister. Thank you. It should be included there. All right, so let's test it here. Python. Is it going to work? Okay, we did it. Here it is. Okay, so that is MNIST. Okay, is there like a fetch function? How do we use this? Do we just run it directly? Do we just do MNIST like this is a function? Oh, look at, there you go. Oh, there we go. That's what we need. Okay, Kevin McAllister, thank you. You solved the problem. That's exactly what we need. Here we go. So let's copy and paste it again. Thank you, Kevin McAllister. So you know what that means? You know what that means? The Quickstart tutorial is bugged out. It means the Quickstart tutorial is not correct. That means there's a problem right here. MNIST. There we go. Training data. So here's our training data. Here we go. Let's see if it runs now. Let's see if it runs. Quickstart. Oh wait, of course, because I need to get rid of that now. There we go. Now we're good to go. Good. That's totally fine. We're doing the beginner stuff. This is beginner stuff right here. Although we are going through the Quickstart tutorial, Kevin McAllister knows better. Kevin McAllister, you guys, definitely knows better. All right, let's copy and paste this. This is the training start. Let's walk through this really quick. All right, so let's do set paste. Paste it in. Set no paste. All right. Okay, so let's jump in here. We already got that. We're good to go. So now let's train. We'll do the training loop. Perfect. 1,000 samples. It looks like it's going to train 1,000 samples or 1,000 batches. What is the batch size? Oh, batch size is going to be 64. So we're going to batch size of 64 because we're doing stochastic gradient descent. So random init sample, and then it's going to create the batch through our training data with the sample. And then let's see here. The labels is the output. This is the training data. The MNIST section of the docs. Is that it? Okay. All right. So that actually was the thing. We just got to read the docs. Thank you for reading the docs, Kevin McAllister. You saved us because the Quickstart was busted. All right, so labels is the output data. So that's the actual answers. So the AI, the input, this is the image data, right? Right here's the image data. So the image data looks like this. Let's pop over to the image data real quick. So if you're familiar, the image data looks like this. These are our numbers, right? Our handwritten numbers, the image data. The output is the actual representation of those numbers. So like 0, 1, 2, 3, 4, 5. So that's the actual numbers. Then we do a forward pass, which runs the data or all these 64 numbers, basically 64 numbers through the model. The model is going to give us the answers, and that's their output. The output initially is going to be wrong. It's going to give the wrong guesses. It's going to give us the wrong data. So now we compute the loss. So we know what the actual answers are, and we know what the AI gave us the output for. So we're going to calculate how wrong the model was. We're going to create a delta. Stream idea. That's from Kamala. All right, so we got to write that down. From, who is this from? Kamala Karreddy. Kamala, wait, I don't know. Kamala Karreddy. Is that how we say your name? Kamala Karreddy? Is that how we say it? All right, that's the answer. That's what we got. So that'll be a future stream. We can do some AI agents, you guys. How did you make your own live transcription? Hey, Doran Phillip. Here you go. I've got your answer. Check it out. Go to Twitch. Let's see, Twitch subtitles. I could type correctly here. Subtitles. GitHub. Stephen Blum. Just type that. Get that. And then you can see it. Because it's my own software. I wrote it myself. It's available for free. It's completely for free. We'll let the AI figure some stuff out here. I don't know what it is, but one of the problems that we're running to with the Tinygrad is since the backend, it doesn't seem to be very well supported. If we were running this on PyTorch, we definitely would not be having the same issues. And because we hit some issues with NumPy, and we also hit some issues with it crashing. It outright crashes. Like we have scenarios where it outright crashes. How do tensors work? Oh, okay. So a tensor is just an array. That's all it is. So you can just think of it as an array. So Python, let's just jump into this really quick. So here's a tensor. So here's a tensor, 1, 2, and then you say, comma, 3, 4. Here we go. There you go. That's a tensor. Absolutely can. Why not? You totally can. I love to see how you talk. Okay, how do tensor works? I always join to the stream. Can I train a similar project? Yep. Okay. Sorry if I'm trying to catch up on all the chats, you guys. Print copium for Python. Hey, let's do it. I know. Let's do it. All right. We'll print copium. Print copium. Right. We're copium. We're coping right now. Testing out the Tinygrad with Python. We did with Tinygrad, but unfortunately, we're gonna have to say goodbye to Tinygrad. It was a lot of fun to use, but unfortunately, we'll have to go back to PyTorch, which is totally fine.